in the purpose of this video is to understand when we change the height from the surface of the earth, then gravitational acceleration, the value of the gravitational acceleration which we believe is constant, would that be constant, or do you think that this will not be constant and this will vary? Because in the previous lecture we have discussed what we have taken in terms of when we are discussing about anything which is lying over the surface of the earth. We have taken the radius as the distance between these two objects, the earth and that particular object. But now when we are considering one person who is sitting above the Eiffel Tower, let's say for example one person who is sitting here, okay, one person sitting here, and I want to find whether this person will experience a same gravitational force as well as one person who is basically standing here. Do you think that these two person will experience the same gravitational force, or do you think that they will not experience the same gravitational force? Because the gravitational force is definitely relied on the gravitational acceleration. So if we understand what is the variation of the g with respect to height, then we'll be able to understand everything. All right, so let's start with the formula what we already have derived. Okay, so the formula is this: g is equal to gm by capital R square. Okay, so this is the formula when the object is over the surface of the earth. Now as you can see, this person number 1 and this person number 2, this person is not over the surface of the earth. So definitely let's take the height of the Eiffel Tower is h, for example. So let's take the height. So in order to insert this one single line, we need to quickly sorry, for inserting the height, let's say this height is let's take different color, let's say. Okay, so this height is, yeah, let's say this height is h. Although the height of the Eiffel Tower is approximately 340 meter, or if you not going to the top, if you are talking about this particular space, then this height is 300 meter and this one is 340 meter. Okay, so I know that, but we are not applying here that 340 meter, that is the height. Okay, let's take any general case where the height over the surface of the earth is h. Okay, and now the radius, let's say for example the radius of the earth is r. All right, so we are drawing, let's say this is the center and the radius of the earth is r. Okay, so if the radius of the earth is r and the height and the height is h, then we can write that if we consider that the gravitational acceleration at the point at the top of the Eiffel Tower, for example, let's take this point is P. Okay, at the point P, let's say gravitational acceleration is g dash. Okay, and over the surface of the earth the gravitational acceleration is g. If that is true, then we can say that the g dash is equal to gm plus r plus h square, because we know that this height of the P from the center of the earth, from this very origin of the earth, from the center of the earth, is equal to r plus h. All right, so now what we are going to do is we are dividing equation number 2 by 1. So if we do that, then what will happen is g dash by g is equal to r squared by r plus h squared. Okay, so that is the very straightforward case. So from there we can get the value of the g dash is equal to r square plus r plus h square. All right, so now we need to go a little bit about, we need to go through a little bit of mathematics. We need to take a little bit help of mathematics. Let me confirm that we will be using a couple of topic from the binomial expansion. So I will highly encourage you, and I'm highly encouraging you right now to learn a little bit about the binomial expansion. Okay, so the next step is this r square, that what is staying over in the numerator will remain there, and I want to cancel this r square. So in that, for that purpose, we are taking out r square from the bracket, and that's why we will get 1 plus h by r whole square. All right, now as you can see, this r and r are getting cancelled from numerator and the denominator. And the next step, what we are doing, basically 1 plus h by r in this bracket, we are bringing this to the numerator. Okay, so we want to take this term 1 plus h by r to the numerator, and if we do that, then what we need to do, we need to write here a minus 2, because this is the 2 is the power. So now, right now, we're going to use the binomial expansion. Before we proceed with the binomial expansion, I want you to remember a couple of formulas. So number one formula is this. I'm sorry, this ink is so fat. So the number one formula is this: 1 plus x to the power 1 is basically 1 plus x square plus x cube and so on. 1 minus x to the power minus 1 is also 1 plus x square plus x cube plus so on. Now 1 minus x to the power plus 1 is equal to 1 minus x plus x square minus x to the power cube and so on. And last but not the least, definitely, is 1 plus x to the power minus 1, and this is basically 1 minus x plus x square minus x cube and so on. If you look closely, we have a pattern. What is that pattern? If you look very closely, then you'll be able to understand that the alternative minus appears when there is a plus and minus sign in the inside of the bracket and is in the power. You can see that the alternative plus minus sign, if that is present, if the two indices are equal, for example, here plus, so if the two indices, like two symbols, plus symbol and minus symbol, two operations, in other words, that is basically sophisticated. So if we see that this plus sign are both of the signs are plus, then we can get all the terms that is positive. If we get all the term negative, that is 1 minus x and minus 1, then we will get again all the terms are positive. So if the symbols are equal, then all the terms will be positive. If the symbols are unequal, for example, minus plus or plus minus, doesn't matter, and we have to introduce an alternative minus sign. All right, so I think we can remember that. So if you have remembered that one, then we can proceed with the whatever we have done till now. So g dash is equal to 1 plus h by r to the power minus 2, right? And from this equation we can get, if we take h by r equal to x, then what we can get is that 1 plus x to the power minus 2. So what formula we can use here? The formula, which is basically minus 2, this one, the fourth one we can use basically. So we can write in the very next step is that 1 minus, okay, 1 minus, this is basically 2, so this power will come in the front, so minus 2h by r. Right? So now the rest of the term we are ignoring because of the binomial. The rest of the terms, definitely there will be square, so plus, let's say for example 2, so we need to write down like 2 square by in the next step 2 factorial by h r square, the next step h cube, 3 factorial h by r cube and so on. Okay, so if you look at this formula, if you look at go on with this series, then you'll be able to understand that this h by r, this ratio is increasing, the power of this ratio is increasing with the each and every a term which is basically coming after, right? So if you look at this h by r ratio, let's say for example in the case of the Eiffel Tower, I can see that the Eiffel Tower height is approximately 300 meter. So 300 into 10 to the power minus 3 kilometer, and r is basically 6400 kilometer. So if you look at this ratio itself is very small. Now if I square this ratio, then what will happen is that then we can get that 3 into there is a 10 to the power minus 1. So I can write 64 into 10 to the power 3. Okay, so now if I do the square, then it will become 3 by 64 into 10 to the power minus 6. So now you can see that 10 to the power minus 6 is very small number, so we can ignore that, right? 3 by 64 into 10 to the power minus 6 is very small number. Similarly, in a similar way, you can get that for the cube, right? H by r cube. If you look at this term, then also that is that will end up getting 3 by 64 into 10 to the power minus, like for example 9 and so on, right? So you can see that all the terms, all the preceding terms will become very, very less. So in that case, we are taking all these terms are negligible or almost goes to 0. So we are left out with only first two terms, and this is basically 1 minus 2h by r. That is value of the g dash. Now we have forgot to write this g over here, because there should be another g, and yes, there should be another g, and there should be another g, there should be g, and there should be another g. So this is the formula for the height. So yes, you need to remember this formula, and yeah, that's it for g dash equal to 1 minus 2h by r into g. Now you can clearly get the idea is that whenever we increase the height from the surface of the earth, then the value of the g will decrease, because this value of the 2h by r, this will be a very small number till the value of the acceleration is getting decreased, because there is a minus sign. All right, so we can see that the value of the acceleration will decrease when we move from the surface of the earth towards the sky, or towards the outside of this surface of the earth. The value of the g will decrease. That's all. See you in the next class.